we're going to talk about how to shift functions and how certain numbers in certain places affect the direction that those graphs are going to shift. So we're going to go through several examples. In the first one, exercise 1, we're going to go ahead and graph the absolute value function x. So that function, you might remember from Algebra 1 or prior lessons, but that function has values, y values that are positive, because absolute value means you have a positive answer. It's a distance in numbers from 0. So here is our first function, the absolute value of x. Now we're going to go on and use the calculator to graph the next one. And what we're really going to focus on is the turning points of those functions. So if you take the next one, and to get the absolute value, press the math button and then the arrow. So we got x minus 3 inside plus 2. I'm going to go to the table. Now you'll see that I'm going to highlight this point right here. 3, 2 is the turning point. So that's where my graph turns at. So I'm going to do that one in red. And then from there, the graph goes diagonal like it did for the other graph. So that's our y equals absolute value of x minus 3 plus 2. And then I'm going to go back and put in the other one, which was plus 1 and minus 4. And then you'll see here, this one has a turning point at -1, -4, because you see those repeat y values around it. Now, one misconception is that people think that the graphs are getting bigger or smaller, and they're not getting bigger or smaller. They're the same size graph. The lines go on forever. It's just that the part of the graph that we're graphing, and you see, has a restriction. Now, going to the questions, it says for B, we got our table, and we graphed those functions, and we labeled each. So for C, based on what we talked about, how would the graph of absolute value of x be shifted in order to produce the graph of y equals the absolute value of x minus 6 minus 8? Well, in this case, based on what we just talked about, and those turning points, this one should have a turning point of 6, -8. So this graph should shift 6 to the right, and 8 down. So that kind of brings us into our rules when we're talking about shifting. If you go below in 1 and 2, if you add or subtract the number at the end of the function, that's going to shift it up or down depending on how many and what sign you see. For the horizontal, if it's a positive value, like it says here, if k is positive, it's going left that many spaces, and right if k is less than 0. So for this one right here, I know that this new function, based on what they say for f, it's going to shift 3 right and 1 up. So k was less than 0, so it's going to shift right. And the final value is positive 1, so it's going to go up 1. So what you'd want to do is take all the points that you see where the line turns, and you want to go ahead and shift those 3 to the right and 1 up. So I'm going to take each point. So here's the original point. I'm going 3 to the right, 1 up. I'm going to do this next point, 3 to the right, 1 up. And then my final 2. So what you'll see is when you shift it, it's like a translation in geometry. The size of it stays the same, but it's just been moved to a different location. So, kind of like I was just talking about, identify how the graph of f has been transformed. Well, we shifted 3 to the right. And 1 up. So if you have a specific function like a quadratic or absolute value, go by that turning point. but you can also go based on the equation as well. So we're going to move on to some of the ones on the back. Now, it says for 3, a function has a domain from -3 to 10, and a range where y is less than 22. And they want us to say what the domain and range are if we are to translate it or shift it, those values. So again, that translation would be 7 left and 10 up. So if we're talking about 7 left, that's going to be -7. So as far as the domain goes, the x values are going to be 7 less than what they were originally. So we'd have to subtract 7 from each of these two values. So we'd end up with -10 to 3 for our domain. And then for the range, it says it's shifting 10 up. So instead of 22, our range is going to be less than or equal to 32. Now, if we're going to talk about, and we're going to talk about part of exercise 4, well, they give us this quadratic function in vertex form. So they're asking how this has been shifted. Well, this one's going to be 4 to the right and 5 down. Now our new graph, 4 to the right and 5 down, is going to be the turning point, which is 4, -5. So for C, they want us to do a sketch of f. So again, if I'm just going to do a sketch, I'm just going to draw in a grid. We got our x and y axis. And they want us to figure out when the domain is increasing. So I know it's 4, -5 for the turning point. So if I put that point, and then I draw the quadratic from there, I know it's going upwards. In this case, my x value is 4. So I know that the graph is going to be increasing when I have a value greater than 4. So I can do x is greater than or equal to 4 in this case. And they're asking which has a lower minimum value, the function f or this function g. Well, looks like g is going to have the lower minimum because the y value, the shift for y, is -10. So g has a minimum of -10. So the g of x has a minimum of -10. F of x had a minimum that was -5. So this one is the lower minimum in that case. So as you go through the other questions, one thing to think about again is what direction are they shifting? Double check that, especially with the x value, because that one's kind of backwards. And also, remember, if you do have a quadratic function or absolute value function, focus on finding those turning points of those graphs as you are doing the shifting.